In this video we have an overview of trigonometric functions, more like a review. So in the first set of problems we want to convert each angle to radian measure. So we have degree measure, we want it in radian measure. So we know that 180 degrees is equivalent to pi, and this is radians. We usually leave the unit here for radians off, but this is understood to be radians. If it's degrees, we have to put it in there. Then if I divide through by 180, in other words, look at 180 degrees as 180 times 1 degree. Divide by 180, I get pi over here on this side. 1 degree is equal to pi over 180. So we can convert from degrees to radian just by multiplying by pi over 180. So we look at this one here. You can look at this as times 1 degree. So the 260 is multiplied by 1 degree, but 1 degree is pi over 180. And we're going to leave the answers in terms of pi. If they want a decimal approximation, you can round off accordingly, but in this case we have the zeros divide out here. Then 2 into 26 is 13. 2 into 18 is 9. So this reduces to 13. This is 13 pi then over 9. Leaving the answers in multiples of pi. Same thing in this one. Minus 400 degrees. Write this as minus 400 times 1 degree. So this becomes minus 400 times, and then replacing the 1 degree by pi over 180. Now we can reduce here by 10, divide these out, divide 40 by 2, and 18 by 2. So this comes out to minus 20 pi over 9. And again, we leave the units out, but this is understood to be in radians. Minus 20 pi over 9. That's understood to be radians. This one over here, in the same thing, it would be 13 times 1 degree. Same way, place the 1 degree by pi over 180. And this one we can't reduce, so we leave it in that form. And of course, keep in mind that here, 180 degrees equals to pi. If I divide through by pi, this, remember, is understood to be radians. So if I divide by pi, I can say 1 radian would equal to 180 degrees over pi. So if you got the measurement in terms of radian measure, and you want it in terms of degrees, then you just multiply by 180 degrees over pi. Simplify. The next set of problems here, I'm going to find the exact value. So for this one here, we write this as the cosine. Now if you're more comfortable working this in degrees, you can do that. Pi over 4, this is 180 over 4, it's 45 degrees times that negative 25. And because the cosine is even, I can just drop the negative and write this as cosine of 225. And the other one, this is minus cosine. Again, pi over 4, that's 180 over 4, that's 45 degrees times 3. This comes out to 135. And it wants exact answers, so on this one we don't really use a calculator. Cosine of 225 degrees has a reference angle of 45. So this is going to fall in quadrant 3. And of course in quadrant 3 the cosine is negative, so I expect this to be negative. And then the reference angle is 45, and the cosine of 45, you should know, is the square root of 2 over 2. Or it could be 1 over the square root of 2 and then simplifies to that. Got a minus there. And then the cosine of 135 is in quadrant 2. Cosine is also negative there. So we take the cosine of 45. Again, we get the square root of 2 over 2. But because it's in quadrant 2, again, this is negative. And this negative here makes it positive. So basically, again, minus radical 2 over 2 plus radical 2 over 2. So this simplifies to 0. Now for the next one, I have sine squared of an angle plus cosine squared of an angle of the same angle, so those are the same. So that's one of your basic fundamental identities. Anytime you have the sine squared of an angle and plus cosine squared of the same angle, that's always equal to 1. So that's what we get here. 0 on this number 4 and 1 on number 5. The next one, evaluate each expression to 3 decimal places. In this set of problems, you'll use a calculator. So you simply put your calculator, make sure this is degrees here. So take your calculator, set it to degree mode, and that's just a matter of hitting your sine function, entering 17, and then rounding off. This is going to be 0.292. Now the next one is cosine of 2 pi over 5. Of course, this is now is radian. So when I use the calculator, set your calculator to radian mode, and then just enter 2 pi over 5. Hit enter, one dot to 3 places. You get 0.309. Rounding out to 3 places. So your calculator in general will have the sine function, the cosine function, and the tangent. Usually doesn't have the reciprocals. So for something like this, you have to rewrite it. If you have it in degree mode, you know that the secant and the cosine are reciprocals. So this would be then secant of 229 is going to be 1 over the cosine of 229. Calculator now here is set to degrees again. For number 7 it was set to radians. So 229. So secant of 229 degrees is the same thing as 1 over the cosine of 229. Notice I didn't put a degree here because the calculator is set to degree mode. So it knows that this is in degrees. Then you just hit enter and round this off to 2 places. So negative 1.524. Solve each of the following problems. So these are just random problems that you might encounter in different chapters of your trig study. So this one says if f of x is equal to sine of x and f of a is equal to 3/5, find f of minus a. So let's just start by saying, okay, what we want to find. We want to find f of minus a. A just represents a value and it's minus that value. So f of minus a equals to, and remember the function f of x is equal to sine of x. So evaluating this thing at minus a will simply give me the sine of minus a. And the sine function is odd, so that means I can bring this negative out in front. The cosine is even, so there I can just cancel it. So this becomes minus sine of a. But keep in mind that f of a would equal to sine of a. But that's given to be 3/5. So sine of a is 3/5. So this is negative, and I just replace sine of a by 3/5. So f of minus a is the same thing as negative 3/5. Okay, look at the next one. Find the value of the remaining 5 trigonometric functions of theta if sine of theta is equal to 5/3, or 5/7 rather, and theta is in quadrant 2. So by definition, sine of theta can be written as y over r, where r is the radius of the circle containing that point, just like in the unit circle. So here I'm going to say y is equal to 5. And I'm looking at this equation here. X squared plus y squared is equal to r squared. So we look at this as theta is in quadrant 2, so the angle comes out this way. It looks like this. And I know that y is 5, so that would be 5 squared, that's 25. And this distance here from the origin to that particular point right there is going to be the radius here, which is given to be 7, so r is 7. 7 squared is 49. So let's solve this for x. First isolate the x squared, subtract 25 from both sides. I get x squared is equal to 24. And then 24 is 4 times 6, so I take the square root of that. Square root of 4 would be 2, and the 6 stays under the radical. And because I'm in quadrant 2, the x has to be negative in that area there, so I put a negative right here. So I got y is equal to 5, and of course r is equal to 7. So you can think of this angle in standard position, and this point right here would be xy, where x is minus 2 square root of 6. The y value is 5, and this radius from the center to that point is equal to 7. Well, with that information, you can find the value of the other one. So we know this is given, so the cosine would be x over r. So x is minus 2. I'll just go to 6, and r is 7. There's the cosine. The cosecant and the sine are reciprocals, so I can just say, okay, that means if I know the sine, the cosecant of theta would just be the reciprocal of this. 5/7 would be 7/5. You get this. And then the tangent of theta would be the y value, which is 5, over the x value, which is minus 2 square root of 6. And then we usually want to rationalize this, so multiply by the square root of 6, numerator and denominator. On top I will get 5 square root of 6. Then square root of 6 times the square root of 6, that's the square root of 36, which is 6, and then times the negative 2, that'd be at negative 12. So this will be a 12 here, and I put the negative on top. So that's your tangent. And then the cotangent of the angle, theta in this case, tangent and cotangent are reciprocal, so I can just take the reciprocal of this answer, and it's better to take it from this point here. That way you have the radical on top, and the denominator will be rationalized, so this will be minus 2 square root of 6 over 5. Minus 2 square root of 6 over 5. And all we need now is the secant theta. Cosine and secant are reciprocal, so I just take the reciprocal of this answer here, so this will be 7 over minus 2 square root of 6, rationalized by multiplying the numerator and denominator by the square root of 6. That'll give me, I'll put the negative on top here, minus 7 square root of 6, and here this will give me a minus 12. That's the 6 values that we wanted. Okay, this one is kind of similar. It says if the point 27, but it already tells you the information, if the point 27 is on the terminal side of an angle theta in standard position, find the exact value of sine of theta. So the point 27, if I plot that point, I go over 2 and then 7 up, so this angle would go like that. So we consider this angle right here, and this continues up, of course, but this point here on the terminal side is 27. That's x and y. And the distance from the center to that particular point, that's the radius, so that would be r, and that's just going to be the distance completed. So it's 2 minus 0 squared is, that's 4. Using the distance formula, 7 minus 0 is 7 squared, you get 49. And then this is going to give me the square root of 53. So we want the value of sine theta. Now with that information you could get all the other ones also, all 6 of them, but we kind of did that in the last problem, so here is just one of them. Sine theta is equal to the y over the r, so this will be 7 over the square root of 53, and we just rationalize, multiply the numerator and denominator by the square root of 53. It'll give me 7 square root of 53 in the numerator, and then when you multiply the denominator by the square root of 53, it comes out to 53, because it's 53 square root of 53 squared. So this is just 53 down here. And that's your answer. And the last one here says write the equation of a sine function with the following properties. Okay, it tells me the amplitude is -3, the period is 2 pi over 3, and the phase shift is -pi over 4. And we have this formula right here for the graph of y equal a sine omega x minus phi, with omega positive. The amplitude, if it's in this particular form, the amplitude is absolute value of a, period is 2 pi over omega, and the phase shift is phi over. So we have to just fill this information here. We know the a here to be -3. Now we need omega here. We have the period to be 2 pi over 3. So let's see. Period is 2 pi over 3, and the way we find the period, we take 2 pi, and when it's in this particular form here, we divide by whatever multiplies the x, which in this case is omega. We got 2 pi, 2 pi. This should be very clear that this would mean that omega is 3. So we got that value there. Now the phase shift is obtained by solving this part right here for x, setting that equal to 0, and solving for x. So if I do that, let me just put it over here. So bringing this over, divided by omega, then we get x is equal to phi over omega. But we found already omega to be 3, so this is going to be 3 here. So we get then phi over 3 is the phase shift, and that phase shift is given to be minus pi over 4. So multiply both sides by 3, so that tells me that angle phi is equal to minus 3 pi over 4. So now let's put it all together. Say the equation would be y equal to Let's plug it in here. Amplitude, but the coefficient there would be -3. And then this will be sine. Put the inside here. Omega is 3, so this will be 3x. So we have the 3x there, and then we have a minus here, and then phi. But phi is minus 3 pi over 4, so if we minus that, that'll make it a plus 3 pi over 4. And this is the equation of the sine function that has those properties. Thanks for watching. We'll see you next time.